Hi, and welcome to another Level 3 differentiation video. In this video, we focus on trigonometric functions. Let's quickly talk about the functions you've seen so far, the sine, cosine, and tangent functions, sine, cos, tan, and talk also about the three new functions this year, the secant, which gets shortened to sec, the cosecant, which gets shortened to cosec, and the cotangent, which gets shortened to cot. Some of you would have come across these if you've already done the trigonometric standard this year. All right, well, here's a list of the table of what all the functions differentiate to. The good news is you don't have to remember this. They are all provided on a Level 3 mathematics formula sheet. Right, before we get into some examples, let's talk about a couple of key things. The first thing, if the function y is equal to a number a times sine x, I'm just going to use sine as my example in both of these ideas here, then the y dash, the derived function, will become a times cosine x because sine differentiates to cosine. If, however, the function y is equal to a number a times the sine and inside the brackets there's another function u, this is a composite function. There's a function inside the sine function. So then y dash will become a times cosine of u, but then we must times it by u dash, which is the inside function derived. It's an important part here. This composite idea will make up a big part of these trig functions. All right, example 1. Let's differentiate y equals 5 sine x. Looking at the table, sine differentiates to cosine, so y dash will become 5 cosine x. That's simple. Let's move on. Example 2, differentiate y is equal to 4 cosine x plus 2x. Well, looking at the table, the cosine function differentiates to the negative sine function. So y dash will become negative 4 sine x, because cosine differentiates to negative sine. Now we've just got the plus 2x to differentiate, and we remember a number by a letter differentiates to the number, so it just becomes plus 2. All right, example 3. Let's differentiate y is equal to 3 times tan bracket x squared. Well, now we're into the composite function idea, and this is the u is equal to x squared. It's a function inside the tan function. So, looking at the table, we know the tan function differentiates to the sec squared function. Sec squared x is just simply the sec function all squared, and that's how we write it in mathematics. So, y dash is going to turn into 3 sec squared bracket x squared, but because it's a composite function, we must times by u dash. Now, if we come back to the box and work out u dash is 2x, then we can replace u dash with 2x, and we can write down our final derived function. There will be some people who will want to multiply the 3 by the 2x and write it as 6x times sec squared bracket x squared. All right, and finally, example 4. Let's differentiate y is equal to sec bracket 5x. Well, once again, this is a composite function. We have u is equal to 5x, a function inside the sec function. Looking at our table, we can see that the sec function turns into the sec function times the tan function. So y dash will become sec of 5x times tan of 5x. But because it's a composite function, we must multiply it by u dash. Now u dash, if we come back to our box, is just 5. So we'll replace u dash with 5, and we'll write down our final answer. We like to put the 5 out the front. Y dash is equal to 5 sec bracket 5x times tan bracket 5x. Great, thanks for watching.